Yes. I understand you were discussing, Sandra told me, and that was very good. You keep up the spirit, okay? So I want us to go to that number B, which disturbed many of you. Are we there?
Yes.
You had 20x plus 84 out of x plus 5 very quickly into x squared minus 9. Are we able to see this?
Yes.
Yeah, as I told you,
Yes.
we are supposed to study the nature of the denominator of any fraction before we start expressing into partial fractions. But also, we added one condition that as you study the nature of the denominator, you need to know, is this fraction proper or improper? Like in this particular case, the degree of the numerator is 1, and that of the denominator is 3 after expanding x plus 5 by x squared minus 9. So since this fraction is proper, then we are tasked with looking at this expression x squared minus 9. Many of you are tempted to think that this is quadratic. Yes, it is quadratic, but it can be factorized. So before you consider a denominator to be quadratic, you should confirm that it is infactorizable, meaning that it cannot be factorized. Therefore, we express this expression as 20x plus 84 over x plus 5, x squared minus 9 being a difference of 2 squares, which can be written as x plus 3 into x minus 3. Is that understood? Yes?
Yes.
Yes.
Yes, so it means 20x plus 84 over x plus 5 into x plus 3, x minus 3 can be written as, now we can see that they have been expressed as a product of 3 linear factors, 1, 2, and 3. So the denominators are all linear, meaning that they carry constant numerator. So you have a over x plus 5 plus b over x plus 3 plus c over x minus 3, which I'm very sure you can now complete. Isn't it?
Yes.
Okay. Away
Yes.
from that, I want us to look at these numbers I've given up here. That we resolve in Roman 1, x cubed plus 5x squared minus 6x plus 6 over x minus 1 squared, x squared plus 2 into partial fractions. You can see that we have x cubed plus 5x squared minus 6x plus 6 over x minus 1 squared into x squared plus 2. Very quickly, is this expression proper or improper? Anyone there? It is proper. Very good. What is the degree of the numerator?
Numerator is 3.
And denominator?
It is 4.
Good. Thank you, Caroline. Now, if it is true that is proper, then now we go ahead to study the nature of the factors involved in the denominator. We have x minus 1 squared, then x squared plus 2. Now, what is the nature of x minus 1 squared? Pardon? Annette? Monica, what is the nature of x minus 1 squared? Emmanuel?
It's linear, but
It is linear, but the power is 2, isn't it?
it's linear,
But repeated, right?
Yes.
So that kind of denominator, we call it repeated linear. Then what about x squared plus 2? What
it's
about x?
quadratic.
It is quadratic, very good. So if it is quadratic,
It's quadratic.
okay, thank you. So if it is quadratic, it means we have to treat x minus 1 squared as a repeated linear factor. And therefore, since it's repeated twice, we shall have a over x minus 1 for the first time, plus b over x minus 1 for the second time. We are done with x minus 1 squared. But then x squared plus 2 is a quadratic factor which cannot be factorized. Remember, it's different from the x squared minus 9. The x squared minus 9 was quadratic but factorizable. So you go ahead and factorize it so that it becomes a product of 3 linear factors. But this cannot be factorized, so it is treated as a quadratic denominator. So what should be the numerator of this x squared plus 2? You can tell us. You can tell us what should be the numerator of x squared plus 2?
Cx plus d.
Cx plus d. Very good. You can see we cannot use b again because we already used b here in the second expression. So we are going to say x cubed plus 5x squared minus 6x plus 6 is equal to a into, if I multiply a by this, I remain with x minus 1, x squared plus 2. Then we have b, multiplying this by the denominator, the x minus 1 squared will go, and I remain with x squared plus 2 only. Now, I have discovered that many of you are not putting the cx plus d in brackets in the exercise I gave. Even this should be put in brackets because it is making many of you not to expand appropriately. So you put the cx plus d in brackets and it will multiply x minus 1 squared. Then you are going to continue. Is that understood?
Yes.
You will continue and submit
Yes,
this.
sir.
Continue and submit this work. And then in 2, we have x squared plus 2x plus 18, all this over x into x squared plus 3 to power 2. Are we able to see this?
Yes.
So what do we see? Is this expression proper or improper? I'm waiting. Is it proper or improper?
It's proper.
It is proper. What is the degree of the numerator, Caroline?
It is 2.
And denominator?
It's 5.
Very good, because when you expand this, you get x to power 4. Again, then times this x, you get x to power 5. So since the numerator is of degree less than that of the denominator, it is proper. Now, we are done with establishing the nature of the fraction. What about the nature of the factors in the denominator? What is the nature of this factor x? Monica,
So it's linear.
It's a linear factor.
is a linear factor. Very good. What about the x squared plus 3 squared?
So it's quadratic.
Only? Remember, it's
But
power.
and repeat it.
It is quadratic.
Quadratic and repeated.
So we call it a repeated quadratic. Can you say repeated quadratic?
Repeated quadratic.
Very
Repeated
good.
quadratic.
Then what about this one? The x minus 1 squared, we said is called what?
Repeated linear.
Very good. So you should know the difference between repeated quadratics and repeated linear. And the technique is the same. We said the x is of degree 1 is linear, so it takes on a over x plus. Now, quadratic, we are going to have bx plus c over x squared plus 3 for the first time. So what should be the third one? Who can tell us?
Cx plus d over x squared plus 3 squared.
We already have c.
No, dx plus e. Dx plus e
Dx.
over x squared plus 3 squared.
Very good. So I just wanted to introduce this element, this part, so that you do not get disturbed when you meet any partial fraction. So you can have a repeated linear or repeated quadratic. Okay. So from here, you follow the same procedures. Maybe I will have to complete this so that we are able to follow. So we have x squared plus 2x plus 18 over x into x squared plus 3 squared. We said we have a over x plus bx plus c over x squared plus 3 for the first time, plus dx plus e over x squared plus 3 for the second time. If it was to power 3, we would have fx plus c, whatever is after f. Now, we're going to say x squared plus 2x plus 18 is equal to a into, now x cancels this, so I remember x squared plus 3 squared plus bx plus c. As I again said, you need to also put this bx plus c in brackets. It multiplies x into x squared plus 3 because the x squared plus 3 reduces this to power 1. Then plus the dx plus e multiplying only x now because the x squared plus 3 squared cancels this. Are we together? So if x is 0, if x is 0
Yes.
for this particular one, for this one or this, we shall do away with this, and it means we have 18 is equal to, if x is 0, this will be 0 plus 3, which is actually 3, squared is 9a. This will be 0, this will be 0. So what is the a here? Sandra, what is the value of 2? Okay, that's good. Now,
2.
A is 2. Now we have to either expand or use simpler values of x, but let's expand because it's what we are familiar with. We have x squared plus 2x plus 18 is equal to a into, we have x squared plus 3 squared is same as that one, multiplied it twice, plus, let's open x inside the other one, we have bx plus c. Opening with the x, we have x cubed plus 3x. And then opening x with the dx plus e, we shall have dx squared plus ex. We shall have a number of equations, but that shouldn't worry us. So we have x squared plus 2x plus 18 gives us a into, when we expand this, we have x to power 4 plus 3x squared plus 3x squared, giving us 6x squared plus 9, I think. Is that okay? X to power 4 plus 3x squared plus 3x squared plus 9. I think that is perfect. Plus, when we open this, we have bx to power 4 plus 3bx squared plus cx cubed plus 3cx plus dx squared plus ex. That should be it. So we have x squared plus 2x plus 18 is equal to, let's collect the terms in x to power 4. What are the terms in x to power 4? Somebody help us collect. Sandra.
A plus B.
A plus b, correct, because we have ax to power 4 and bx to power 4. That is it in terms of x to power 4. Then the terms in x cubed.
Cx.
Cx cubed. So it's simply c, isn't it? In terms
Yes.
of x cubed. Then the terms in x squared.
That is C.
The terms in x squared.
Is
D plus 6. Then there is also 3B.
6.
So we have 6a, isn't it?
Yes.
6
Plus 3b
BB
plus
plus D.
plus d in x what? Squared. Then the terms in x.
9A.
In X, please.
The next is only E.
In X, we shall have
3C plus
C
E.
plus E.
3C plus E, correct. And the constants, those without X, somebody said 9A, isn't it? I think it's the only one, right? So what is the coefficient of X to the power 4?
0.
On this side is 0, correct? Then on the other side,
A plus B.
A plus B. Remember, A is already 2, okay? So if A is 2, we shall have 0 is equal to 2 plus B, giving us B to be negative 2. Then the coefficient of X cubed on the right-hand side
Still
is
0.
it is still 0. So I have 0 is equal to
Zero.
C, isn't it? So C is already 0. Then the coefficient of X squared on the left-hand side is?
1.
So it means
1.
1 is equal to, then what about X squared on the right-hand side?
6
6A.
Hmm?
6 times 2.
Okay, that's true. 6 times 2, which is 12. Is it times? A is what? A is 2. So we have 12. B is negative 2. So we have minus 6 plus D. So we have 1 is equal to 6 plus D. What is D?
Negative 5. I mean,
Yes, isn't it?
yes.
This is negative 5. That's correct. Then what do we need? E. The terms in X, what is the coefficient of X this side?
2.
So 2 is equal to, on the right-hand side,
3C plus E.
2.
plus E. But remember, we already got C to be. Did we get C? C is 0, isn't it?
Yes.
So
Yeah.
if C is 0, I have E is being 2. So we simply substitute there. We are going to say now X squared plus 2X plus 18. Roll this out of all this over X into X squared plus 3 squared should be, we just substitute E in this expression. The value of A we found to be 2 over X plus B is negative 2. So we have negative 2X plus C is 0. So we simply ignore over X squared plus 3 plus B, which is negative 5, of course, times X plus E, which is 2 over X squared plus 3, but squared. Is that okay?
Yes, teacher.
Any question on partial fractions?
Yes.
Because I really want to introduce something very quickly in the remaining few minutes. Any question?
So, I was inquiring on what if given a proper fraction, but okay, what if given a repeated fraction whereby, but in the first, actually, it is one of the questions, the question number 3, the one that you gave us, whereby the first bracket is called is quadratic, then the second bracket is linear.
Do you remember the question of it? I do it quickly.
Yes,
What is it?
it is 5x squared plus 2 over open brackets 3x plus 1 close the brackets, then open brackets x plus 1 squared.
Okay. Is this proper?
It's improper.
What is the degree of the numerator?
No, it's proper, sir.
Proper.
It's proper.
The first factor is linear, right?
Yes,
The second one is repeated linear, isn't it?
yes.
So you simply say A over 3x plus 1 for the linear denominator plus B over x plus 1 for the first time plus c over x plus 1 squared for the second time. The only thing is I think it had fractional values of a, b, and c. Okay. Can you move on from there?
Yes, sir.
Okay, thank you. Allow
Yeah,
me.
I can move on, sir.
Very good. Allow me to introduce the further equations and factors very quickly. We are running out of time. Further equations and factors. Now, we want to begin by those ones that reduce to quadratic equations. Are you able to see my screen here? Further equations and factors?
Yes.
Yes, sir.
So we are going to be handling those particular equations that need some substitutions and they end up reducing to quadratic equations. And the first one is what you see there, that we solve the equation x squared plus 4x over 3 plus 84 over x squared plus 4x is equal to 11. Then we use that example and remove this from you so that you are not just going to follow. Now, what do you see here and here? Are you seeing my pen? Yes?
Yes, sir.
What do you see?
Yes.
What do you see? Here. What do you see?
So they're similar.
They are the same, not they are similar, isn't it?
Yes. Yes.
So since they're the
They're the
same,
same.
you let maybe an unknown y to stand for that x squared plus 4x, okay? So that you
Yes,
have
teacher.
y over 3, because I've made y to be that one, plus 84 over y should give us 11. Then you multiply all through by the LCM. The LCM is 3y. You simply multiply the two denominators to get the LCM. So that I have 3y multiplying now all through times y over 3 plus 3y times 84 over y should give us 11 times the 3y. So that the 3's will cancel and I have y squared plus the y's will cancel. 84 should give us 33y. Collecting the like terms, we have y squared minus 33y plus 84 is equal to 0. Have you seen that it has reduced to a quadratic equation? Yes?
So what of that theory?
There?
The theory.
The 3 where? This one?
There plus 3y times 84. Isn't it supposed to multiply the 3 times the 84?
Yes, you're right. You're right. What is 3 times 84?
252.
252.
252.
Very good. Thank you. So it should be plus 252 is equal to 0. So I was asking, have you seen that it has reduced to a quadratic? Thank you, Sandra.
Okay.
So it is now a quadratic, which we can now solve using any technique that we know. And I think let's do this quickly using the formula method. Y is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So that my y becomes negative 33, you get positive 33. We know this formula. Plus or minus square root of b is negative 33 squared minus 4 times my a is 1 times c is 252. What is negative 33 squared?
1089.
189.
So what is 1089? That is 1089 minus what is the product of 252 by 4?
1008.
1008. What is the difference there? What's the difference there? 10.
81.
81.
So 33 plus or minus root of 81. What's the square root of 81?
9.
Very good. So there are two values of y. Y is 42 over 2. Or what is 33 minus 9? What is 33 minus 9?
24.
24 over.
24.
So the values of y are either 21 or 12, isn't it? Yes? Are we together?
Yes.
Now, but remember, our y was initially x squared plus 4x. So if y is 21, it means x squared plus 4x should be equal to 21, okay? And we have x squared plus 4x minus 21 is equal to 0. What are the factors of negative 21 that give us positive 4? What are the factors of negative 21 that give us 4? 3 and 7? So 7x minus
7 and
3.
negative 0.
Very correct. 21 is equal to 0. So we have x squared plus 7. Okay, actually x into x plus 7 minus 3 into x plus 7 is equal to 0. So x plus 7 into x minus 3 is 0. So the values of x for y is equal to 21 are negative 7 and positive 3. Now, what if y is 12? We go back to what y was. So we have this time x squared plus 4x is equal to 12. Meaning we have x squared plus 4x minus 12 is equal to 0. Factors are positive 6 and negative 2. Am I right? Is that correct?
Yes.
So we have x into x plus 6